Hey, what's happening, everybody? All right, we're going to be learning today section 4.6, which is about using congruent triangles, and it's building on what you've been doing in the previous few sections where you've been proving that two triangles are congruent. Now we're going to continue proving that two triangles are congruent, but we're going to do it with another goal in mind after we prove the triangles are congruent. The goal specifically, you will use congruent triangles to prove that corresponding parts of those triangles are congruent to one another. Now, as we get into this, there's an acronym that I need to teach you and a principle that I need to remind you of, and that acronym you see is CPCTC. CPCTC is something that you're going to be using quite a lot of from this point forward, to be honest. Now, here's the idea with CPCTC. Suppose I told you that in this picture that triangle ABC is congruent to triangle DEF. At the point that you know two triangles are congruent to one another, don't you automatically know that all of their corresponding parts are congruent? So, just me telling you this allows you to conclude that segment AB is congruent to segment DE, segment BC is congruent to segment EF, segment AC is congruent to segment DF, as well as being able to say that angle B is congruent to angle E, angle F is congruent to angle C, and angle A is congruent to angle D, right? Anytime two triangles are congruent, that means that all the corresponding sides and the corresponding angles in those triangles are congruent to one another. And that's the idea behind CPCTC. Now, here's what that acronym stands for. CPCTC means that corresponding parts of congruent triangles are congruent. All right, and then the CPCTC is just the first word in each of these larger words in this acronym. Corresponding parts of congruent triangles are congruent. So anytime you see CPCTC, you need to know that it means corresponding parts of congruent triangles are congruent. And what that boils down to is that if you know two triangles are congruent, then you know all the sides and the angles are congruent to one another. That is a very useful thing. I'm going to show you that right now within this proof. We're going to do two proofs in this video, each in which we're going to use congruent triangles to prove something else. All right, you see in this picture that we're going to prove that triangle CDT, this little triangle up here, is congruent to triangle CFT down there. And we've learned a lot of ways of proving that two triangles are congruent, right? Now, what I'd like to do is I'd like to start marking down the information that's given to us. All right, so what can we infer from what's told to us? And then I'm going to show you why it's going to take a little bit more for us to prove that these two triangles are congruent than what we're used to working with. All right, now the fact that a segment bisects an angle means it divides that angle into two congruent angles. So if segment CE bisects angle FCD, there's the rest of that, that would indicate to us the angle FCT is congruent to angle DCT. And the fact that segment CE bisects angle FED over here would indicate the angle DET is congruent to angle FET. All right, now keep in mind what we're ultimately trying to do is we're trying to prove that this triangle and this triangle are congruent to one another. I'm going to highlight those real quick. All right, so you got the two purple triangles right there. We're trying to prove that they're congruent to one another. But if you look at the information that we know about those two triangles right now, it's insufficient. Right now we know that they have one pair of congruent angles, and of course we can do the old reflexive property and say that they have a pair of congruent sides, but knowing that one pair of angles and one pair of sides are congruent is not enough to be able to prove that the entire triangles are congruent. All right, so here's where the CPCTC thing comes in. What we're going to do is we're going to look for another pair of triangles that we could prove are congruent that ultimately will allow us to say that there's some additional pairs of sides or angles from these two triangles that have to be congruent to one another. And I'm going to highlight the triangles that we're going to use. It takes a little bit of getting used to see this. So I'm going to highlight them in red. Take a look at triangle CDE and then triangle CFE. If you notice, we already know that two pairs of angles right there and there, and those triangles are congruent to one another. And isn't segment CE congruent to itself? All right. So we would be able to prove that those two triangles that are outlined in red are congruent by angle side angle. Now, what in the world does that do with anything? Well, this is ultimately where we're going with this then. If I can prove that those two red triangles are congruent, then that means that all of their corresponding parts are congruent, doesn't it? And this is going to be helpful because what we're going to be able to do then is we're going to be able to look and say, all right, well, since the red triangles are congruent, segment CD is going to be congruent to segment CF. And then the purple triangles, can you still see the purple? The purple triangles, now we know that two pairs of sides, I should really put two dashes there, shouldn't I? We know that two pairs of sides, there and there, and there, and their included angles are congruent to one another, and so that will make those triangles congruent by side angle side. So, we have to prove that the red triangles are congruent in order to be able to prove that these two purple triangles are congruent later on. That's the idea. Let's go ahead and start with the proof of why the two red triangles are congruent to one another. So I've gone ahead and included the given information, all right, that we had that 1 segment CE that bisects the angles at either end of it. And then the conclusion that we're going to be able to make with that is that those angles were divided into congruent pairs of angles. Now, specifically over here at the left, that means angle DCT is going to be congruent to angle FCT. And then over here at the right, that means that angle DET is going to be congruent to angle FET. I recorded both those facts in the same statement because they have the same justification, the same reason, and that's because of the definition of an angle bisector. All right, next step in our intermediate goal, so to speak, of proving that the two red triangles are congruent. We've just shown that they have two pairs of angles that are congruent. Now we need to show that the included sides of those angles are congruent. So we're going to say that segment CE is congruent to segment CE. And so all of that is enough for us to prove that the two red triangles are congruent. We're going to do that, and then we'll continue. And so there, that's done. Angle side angle. Now, of course, recall that the reason that we needed to prove that the two red triangles were congruent is because we needed to be able to show that these pairs of segments were congruent to one another in order to use side angle side to prove that the purple triangles were congruent to one another. All right. Now, as far as proving that the purple triangles are congruent to one another, we're pretty close to being able to do that, but let's go ahead and follow through with that statement that says why segment CD is congruent to segment CF first. And this is the thing that we led with as far as this video goes. The reason that we know segment CD is congruent to segment CF is because they are corresponding parts of those congruent red triangles. And anytime two triangles are congruent, all their corresponding parts are congruent. So we can justify the fact that those corresponding parts are congruent with that acronym CPCTC. Corresponding parts of congruent triangles are congruent. All right, now where are we as far as proving that the two purple triangles are congruent to one another? Well, we've now proven that they have this pair of sides that are congruent. We've already proven that, written in our proof, that angle DCT is congruent to angle FCT. What we haven't yet written is why the common pair of sides right here for those two purple triangles are congruent to one another. And we need to state then that segment CT is congruent to segment CT, and you know the reason for that. And then finally, we know that two pairs of sides in the included angle of one purple triangle are congruent to the two corresponding sides and included angles for the other triangle. So we can state that triangle CDT is congruent to triangle CFT, and we can do that using the side angle side congruence postulate. All right, so not easy. I wouldn't claim that this section is easy, but you can see how we used one pair of congruent triangles to prove something else, and that is the main idea of this section. Now, I would like to follow through with one more proof in this section. So I need you to copy down this information. And again, it's going to be a situation where to prove what we're trying to prove ultimately, we're going to have to show that there's a pair of congruent triangles that will help us make that conclusion right there. Copy the information down, please. Now you can see from the from what we're trying to prove that we're trying to prove that angle H is congruent to angle J. And let's look at the information that we're given to accomplish that with. We're told that segment HK, so that entire segment right there, is congruent to segment JK, kind of that entire segment right there. And we're also told that segment PK, so just this little portion right here, is congruent to segment RK right there. Now, at first glance, that doesn't seem to have anything to do with angles H and J, and it really doesn't. But here's something I want to show you. It turns out that those two congruences that I've marked down here are going to help us prove that a certain pair of triangles are congruent. And here are the triangles that I'm referring to. And I want to explain each as I highlight them. You see the one that I've highlighted, and can you tell that segment HK is one of its sides and that segment RK is another one of its sides? And then this other triangle that we're going to compare that with, that I've highlighted in orange, you can see that segment JK is the side of it that corresponds with HK from the pinkish triangle, and that segment PK from the orangish triangle is congruent and corresponds with segment RK from the pinkish triangle. Now, with all that said, you see two triangles where we've got two pairs of corresponding sides that are congruent, but two pairs of corresponding sides, congruent corresponding sides, is not enough to prove that those triangles are congruent. I want to point out the other advantage to these two triangles, by the way. Can you see how angle H and angle J are corresponding angles in those triangles? Alright, so if we could prove that the orange triangle is congruent to the pink triangle, then we can prove that angle H is congruent to angle J by CP/CTC. Now, this takes a little getting used to. There turns out to be a chance to use the reflexive property here. But it's not the reflexive property with segments like you're used to seeing. It's actually the case that these two triangles share the same angle. And I'm going to point that out to you right now. You see how angle K right there is one of the interior angles in both triangles? And it's going to have to be the same measure in the pink triangle as it is in the orange triangle, right? So, we're going to be able to prove, just look at the orange triangle real quick, that two sides and the included angle of the orange triangle are congruent. Now we're looking at the pink triangle to the two sides and the included angle of that pink triangle. And so those triangles can be congruent by side angle side, and then we can use CP/CTC to show that these two angles, corresponding angles of those congruent triangles, are congruent. Let's write the proof, but you've got the plan in your head now. Okay, so we're proving that the pink and the orange triangle are congruent to one another first, and here is a statement that says that they have two pairs of congruent sides, basically. We still need to state that their included angles of those pairs of sides are congruent. So now we can say that angle K is congruent to angle K, and that's a use of the reflexive property of congruent angles. I'll still just write reflexive property of congruence. Alright, now that is enough to prove that those two triangles that I highlighted are indeed congruent to one another. Now keep in mind that you want the corresponding parts in order when you write this congruent statement, and I hope that you can see that this vertical line that I'm tracing right now would be kind of a line of symmetry that you could use to reflect the pink triangle to match onto the orange triangle, right? So H would correspond with J, R would correspond with P, and K would correspond with itself, basically. Let's say this is the congruent statement. Triangle HRK is congruent to triangle, and then we said from the orange triangle that J corresponds with H, so we'll put that first. And then again from the orange triangle, P is what corresponds with R, so that will go next. And then K ends up corresponding with itself. Side angle side is the justification. Alright, now again, why do we care about proving those two triangles are congruent? Because that wasn't our main goal. Well, since angle H and angle J are corresponding angles of those congruent triangles, we now have enough evidence to conclude that angle H is congruent to angle J. And the reason that they're congruent is because they are corresponding parts of congruent triangles. So CP/CTC, corresponding parts of congruent triangles are congruent, is our justification. That's how you use congruent triangles to prove other things. That's the goal I need you to take away from this lesson. Thanks for watching.